Hello, this is Terry Kim from Physics 2, and I'll be explaining about what I did in the second experiment, lines of charge. So for the introduction, I conducted this experiment to determine the amount of charge on a U-tape through exposing it to an electric force. And the concept that I've used in the experiment would be gravitational force, electric force, Coulomb's law, electric field for a charged rod. So to take concepts into depth, I have used Coulomb's law to explain the charge interactions between each of the U-tape and the resulting forces. And the gravitational force was used to explain the gravity exerted on the U-tape, and the lines of charges was used to explain the charge rod, which is an evenly distributed charge tape as a rod, and we have used the line of charge model to calculate the electric field on the charge tape. The sources that were possible for the experiments would be mostly composed of Kuhlmann errors, and for the first one would be just the miscalculations happening for getting the data in the tape, such as distance, mass, surface area, and those stuff. And we have assumed the two tapes to be perfectly identical. However, the two tapes might not be perfectly identical, and also when handling the tapes, the charges might have been lost due to the contact with the hand and the tape. We have made three assumptions for the experiment. The first assumption would be the air resistance is ignored and charges are evenly distributed along the tape, and top and bottom pieces of the tape are regarded as identical tapes. The results collected from the lab 1 is composed of massive tape lengths, area, tape distance, the magnitude of gravitational force, magnitude of electric force, charge on tape displayed in the slide. By using the data from lab 1, I have successfully obtained the data of the charge on the tape, which is 3.98 E minus 9 times coulombs, and the magnitude of electric force on the top tape and magnitude of gravitational force on the top tape was calculated. The code on the left side that I've used is that I've input the data of the mass, the net charge and distance between two tapes, and the code on the right side was used to obtain the electric field of the tape and the gravitational force. So by using the code on the left, I resulted on ending up successfully displaying all the errors of gravitational force, repulsion, and electric force exerted on the tapes. There are two discussions dealt in this experiment, and the first one is, what if I have to use not as a line charge model, but using the point charge model as when dealing with the charge of the tapes. And the 3.98 E minus 8 coulombs are the charge that are obtained by using the line charge model. And when comparing between the point charge and line charge model, the line charge model was greater than the charge from the point charge model. So when comparing those two calculations from different models, the line charge models takes the tape to be evenly distributed along tape, while the point charge model takes the tape as a single charge point. Here we have assumed the tape to be evenly distributed charge, which is more similar to the line charge model assumption. Therefore, I have concluded that the line charge model calculation would be more similar to the real value of the charge of the tape. And ending up discussion, the difference of the estimate between two calculations would be happen because we have used as a different perspective of point of charge on the tape.